Hello and welcome. So we're going to be talking about the Pythagorean Theorem and trigonometric ratios. So when we're looking at this, let's do a little bit of review to build up. So first off, you have a triangle, and this particular triangle is what we also call a right triangle. And you get to call that because we have a right angle denoted by a box right there. Now of this, you have what's called the hypotenuse, and that is the side that is opposite of the right angle. Okay, so across from the right angle is what we call the hypotenuse. Now, with that, we also have the other two sides. We just call them the legs of the triangle. So if it's not the hypotenuse, call it a leg. All right. So when we're talking about what theorem relates to right triangles, well, for sides specifically, we're going to call that the Pythagorean theorem. I'm going to abbreviate that, THM. Now, when you're looking at this, I'm going to write it hopefully a way that is familiar to you. So it is leg squared plus the other leg squared equals the hypotenuse squared. So what that means is that if I take the length of whatever this leg is and I square that length, add it to whatever length the other leg is squared, that length, that should be equal to whatever the hypotenuse's length is squared. All right. Now, this is most commonly known. If I ask students what the Pythagorean theorem is, they usually say a squared plus b squared equals c squared. These are the two same things. They are absolutely the same. All right. So when we're talking about this, though, the reason why I don't write it as a squared plus b squared equals c squared is because generally students sometimes have a hard time remembering that A and B are required to be the legs, C is required to be the hypotenuse. All right, so make sure you're not confusing that. Super easy to just think leg squared plus leg squared equals hypotenuse squared. Okay, so let's just practice Pythagorean theorem really quick, then we'll go right into trig ratios. So for this one, across from our right angle, right, is our hypotenuse, which means our Pythagorean theorem is first leg squared plus the other leg squared equals our hypotenuse, which we don't know. It's labeled as x squared. So we have 14 squared, 196, plus 6 squared, 36 equals x squared. And when we combine that together, we end up at 232 equals x squared. Right? Undo squares with square roots. Now, technically, you just took a square root. You should have plus minus attached to this. However, keep in mind, we are talking about lengths here, and lengths cannot be negative, which means that yes, plus minus, but we're not going to have to worry about the minus today because you're talking about lengths. Those can't be negative. All right, but we do need to simplify if we can. So, for example, when I'm looking at this, I'd say, okay, let's break it down. That's 2 and I want to say 116, but I need to double check. So 232 divided 2, yes, 116. Should have trusted myself on that one. 116 is even, so you know at least 2 goes into it. So if we half that, we should get 58. And then 58, still even, which means 2, and its other number is 29 going into that. Now, as you're looking at this, you say, okay, remember square roots, square implies that 2 there, so you're looking for 2 of the same thing. All right, you have 2 2's, which means one of those is going to come out. And then whatever didn't have pairs, which is your 2 and 29, get multiplied to give us 58, and that is what's left inside the square root. So that means that the hypotenuse, your missing side, equals 2 square roots of 58. Done. Okay. All right, example B. Similar idea, your hypotenuse is across from the right angle, so 13 is the hypotenuse. So when we set this up, leg squared plus other leg squared equals hypotenuse squared. Now 13 squared is 169, x squared is just x squared. Now remember, squares and square roots are inverses of each other, meaning that when you square the square root of 122, those essentially undo each other, and you're left with just 122 coming right out. No change or anything else done to it. So then we have, okay, x squared plus 122 equals 169. Subtract that over. And we end up with x squared equals 47, square root, don't need the minus in that plus minus, so x equals square root of 47. Now, 47, fun fact, is not going to simplify, which means that that is your final answer and you're good to go. So that's Pythagorean theorem and the setup you need for the rest of the lesson. So trigonometric ratios, what are they specifically? So when you're looking at trig ratios, there's a couple ways to think about them. A ratio is a very fancy way to say a comparison. All right, it's a comparison of two things. Like if you were asked what's the ratio to people in a classroom wearing hats versus people not wearing any hats, right, you'll be able to give a ratio for that. And it's just comparing those two groups together. Now, when it comes to trigonometric, that pretty much trigonometric is referring, or definition-wise means the relationship between angles and sides of a triangle. So we're talking about trigonometric ratios, we're talking about the ratio or comparison between angles and sides in triangles. Okay, that's really what we're referring to. Probably more information than you needed, but now you know. All right, so before we said that we had the hypotenuse across from the right angle, and then we had a leg, and we had a leg. Well, what if I asked you to take the leg divided by the hypotenuse? Which leg would you use? Because rarely are these two going to be equal, right? And so you'd say, there's no way to know, right? They're both just called leg. So how would you know which one is being referred to? Well, in order to refer to one specifically, we use a reference angle, meaning that we pick one of the angles in the triangle, not the 90 degrees, since that's already stated, right? That tells us what our hypotenuse is. We're talking about one of the other angles in the triangle, so either the bottom right corner or the top corner, in this case for these diagrams. Okay, and we're saying, okay, for this angle down here, that is theta. By the way, that's just a Greek symbol. Heads up, you'll see a lot of Greek, usually in trigonometry. Greek letters usually just refer to angles. All right, so we're looking at this and we say, okay, according to this angle, now, can we be more specific which leg we're talking about? Oh, sure, right? You notice that the leg, there is one right next to theta. In fact, it is adjacent to theta, right? Adjacent means right next to. So we have what's known as the adjacent leg, which is the bottom leg of the triangle, right? And now we can also be a little more specific here, because theta is all the way on the opposite side, right, of the other leg, which means that we call this the opposite leg. So if it's all the way across the triangle, it's the opposite leg, versus if it's right next to your angle, it's called the adjacent leg. Hypotenuse is hypotenuse regardless, right? So what if our theta goes up in the corner? Well, now that leg is adjacent to your theta, so we call it the adjacent leg. And now the other one that was before the adjacent, it's all the way across the triangle, opposite of our angle. So there's your opposite leg. Now the right angle is what determines that hypotenuse, and across from it is right there. Okay, so those are kind of your positions. Now, we said a ratio was a comparison. Now, fun fact, ratios are often written as your absolute friends, fractions, right? You have something over something, like 1/2. Fun fact, you can also call a ratio, it's comparison between 1 and 2, right? So you're looking at this and you're like, oh, okay. Well, now we have different sides of a triangle. We have adjacent legs, we have opposite legs, we have hypotenuse. And we say, all right, what if I wanted to take the opposite leg and divide that by the hypotenuse? Well, you just saw me write those. They took a hot second. There's a lot of letters involved, and mathematicians were lazy people. So instead of saying opposite leg divided by hypotenuse in a right triangle with reference angle theta, what we do instead is we use a code word to talk about those two legs in comparison. And those are your trigonometric ratios. So sine, cosine, tangent, cosecant, secant, cotangent. All right? So all of these are essentially code words. So for example, sine is the code word for the opposite leg divided by the hypotenuse. Okay, so if you ever want to compare the opposite over the hypotenuse, you use the code word sine. All right, now we need to be a little more specific. We're talking about the opposite leg to our reference angle theta. So what we're going to do is, instead of writing sine, cosine, tangent, cosecant, secant, cotangent, right, those are all really long words still. There's still too many letters. So mathematicians are like, we already shortened them to code words. Let's shorten the code words as well. And we only take the first three letters. So sine is shortened to S-I-N, not sin. Not sin, right? Remember, if we're talking like Mr. Joe or something, okay? So if we're talking Mr. Joe, you don't say Mer Joe, right? You know it's Mr. It's an abbreviation. You don't speak abbreviations the way that they are written. You say the actual word they stand for. S-I-N is the abbreviation for sine with that E at the end. Make sure that you include it. All right. So after we write our abbreviation, we have some parentheses and say theta, right? You put the reference angle from which you are looking at that determines the opposite or adjacent leg. And there you go. Now cosine, first three letters, C-O-S, of your reference equals, and cosine essentially compares the adjacent leg to the hypotenuse. Tangent takes those first three letters again, T-A-N, of your reference angle, right, equals, and then it compares the opposite, sit down, I forgot how to spell that really quick, over hypotenuse, adjacent. Whew. Okay, and those are your main three. Now cosecant, C-O-S was already taken, so we changed the abbreviation a little bit and make that C-S-C, right, secant is the first three letters, cotangent, first three letters. All right. Now, these are your main three functions right here. All right. These are what are called the reciprocal functions. Now, hopefully you remember reciprocal in math means flip. So if I have a fraction, if I flip that, so opposite over hypotenuse, we flip it, we get hypotenuse over opposite. That is the cosecant, right? So if you want to go the other direction as a comparison, use cosecant instead of sine, right? Secant is the reciprocal of cosine, which means it is the hypotenuse over the adjacent. Cotangent is the reciprocal of tangent, which means it's going to be the adjacent over the opposite. And there's a couple ways to remember this. I'll give you just kind of like the bare minimum, right? So when we're first looking at this, for the main three functions, the most important ones, we get a really fancy acronym. So, CA, TOA. All right. Now, and remember, an acronym means that every letter of that word represents something, right? So the S represents the S in sine. The O and H represent the sides of the triangle that it compares. So S, sine, opposite over hypotenuse. C, cosine, which is the adjacent over hypotenuse, the AH. And then we have tangent, T, representing the opposite over adjacent, OA. Okay, SOHCAHTOA, they're your main three trig functions. Now, for your reciprocal functions, the way that I personally remember them is I always think S with a C, right? Sine with cosecant, right? You almost feel like sine and cosine feel like they should go together, right? But they don't. I don't know who decided it. It was a terrible decision, but here we are, right? Cosine starts with a C. It's reciprocal. Secant starts with an S. Right? And the only one that sounds like it should go together is tangent and cotangent, and they actually do, right? So S with a C, sine, cosecant, cosine, secant, all right? So those are your main trig functions. So let's actually find them. So find all trig functions for these triangles. Okay, so theta, your reference is down there, meaning that next to theta, adjacent to it is 3. So I'm just going to label that. And then across from it, on the opposite side of that triangle, we have the 4. So that is our opposite leg. And then, of course, across from the right angle is your hypotenuse, right? So let's find those trig functions. So if I want to find the sine from our angle theta, well, we'd say, okay, sine is the opposite side over the hypotenuse. The opposite is 4, the hypotenuse is 5. So sine is the value of 4/5. This is your answer. That is what you put into the answer box. Okay, cosine compares the adjacent side, 3, to the hypotenuse, which is 5. So 3/5 is the answer to cosine. Tangent, from our reference angle of theta, then compares the opposite side, 4, to our adjacent, 3. So 4/3 is your value of tangent. And then once I get those, right, I just know that S with a C, sine, goes with cosecant. So 5/4 is the value of cosecant, because it's just a reciprocal of sine, so we flip that fraction. Cosine starts with a C, its reciprocal is secant, starts with an S. Now reciprocal just means flip, so if cosine is 3/5, secant is 5/3. Tangent and cotangent sound like they go together, because they do. And then that reciprocal just flips the fraction of tangent, 3/4. And there you go. Those are your answers. Those are the ratios, and you're done. Okay, so example 2 kind of brings everything we've done together and starts actually using all of it. So for example 2, we have a leg, another leg, but we don't see any value for the hypotenuse. Well, that's okay, because we have our Pythagorean theorem, right? We know that if we take our first leg, 3 or 12, it doesn't matter which order you go in, square it, plus the other leg squared, it equals your missing hypotenuse squared. You can find the hypotenuse, find it, right? So 3 squared, 9, 12 squared, 144 equals hypotenuse squared. And then we have 153 equals h squared when we combine those. Take the square root, technically plus minus, don't use the minus, don't need it today. And then simplify. 153, well, that's going to be 3 and looks like 51. 51 also is divisible by 3. That is 3 and 17, I believe. Okay, so look at that. You have a pair of 3s, so if 3 comes out, 17 was left, so 3 square roots of 17 is your hypotenuse. And now you're able to find all those trig ratios. So sine is the opposite to the hypotenuse from a reference of A. Notice we aren't given a theta, and that's okay, because it still tells us where to look. A is in this corner here, right? So from A, your adjacent would be 12, because that's right next to A, and the opposite would be 3. So when we say, all right, so if sine is the opposite over hypotenuse, the opposite is 3. The hypotenuse, 3 root 17. So 3 divided by 3 root 17. Now, you're not going to need to rationalize for these ones, but you do need to simplify any fraction you can, right? So for example, we see, remember, outside numbers affect outside numbers, so 3 divided by 3, well, that's just 1. So we get 1 over square root 17. There's your value of sine. Remember, sine's reciprocal is cosecant, so if I flip that fraction, we get root 17 over 1, which is just the square root of 17. There's your next answer as well. Okay, cosine from the reference angle of A is the adjacent over the hypotenuse. The adjacent is 12, the hypotenuse is 3 root 17. That can simplify, right? 12 divided by 3 is 4, so we have 4 square root 17. And then cosine's reciprocal is secant. So all I need to do is take that fraction and flip. All right, tangent from a reference angle of A, right, is the opposite over adjacent. So opposite is 3, adjacent is 12. 3 over 12 simplifies to 1 over 4. Its reciprocal is cotangent, so 1 over 4 flipped is 4 over 1, or in other words, 4. Okay, now this very last one, notice it is the sine of angle B. meaning that your reference angle switches to be in that top corner now. So we're no longer looking at A, you're looking at B, which means that your opposite side is now the 12 and the adjacent is now the 3. So if we're looking for the sine from angle B, now it's 12 over 3 square root 17, which we just simplified for our cosine of A, right? So that would be 4 square root 17, 4 over square root 17. Now, secant of B. For this one, I think, okay, secant's reciprocal of cosine. Cosine is adjacent over hypotenuse, so hypotenuse over adjacent is secant. So hypotenuse, 3 square root 17 over adjacent, which is 3. Right? And then from there, 3 over 3, that's just 1, so we get square root 17 as an answer. And that's it. That's all of them, right? You don't need to rationalize as much when it comes to trigonometry. Still important, right? But not quite in trigonometry. But you do need to simplify any radical and simplify whole fractions. Okay, example 3, find tangent and cosine if sine is 2/3. Now, these are all from a reference angle of theta, but no triangle is given to us. Well, we know all of these are going to be for right triangles. So I can draw a triangle, and as long as it's right, just pretend that's really good. Let me fix that. There we go. Right triangle, that would work. Or if I want my right triangle to look like that, that would work. Or maybe like this. Sure. Doesn't matter what your triangle looks like as long as it's a right triangle. So I like this one personally. I'm going to go with it. Now I need to pick where my theta is. Remember, theta cannot be the right angle. It has to be one or the other. So it's going to be up here or down there. Doesn't matter? No. Pick a corner. I like it being in the bottom right. Sure. Okay. Now, once that's determined, order does matter. Because you're saying that from theta, right, from theta, you were looking at the opposite and the hypotenuse from that reference. The opposite is going to be that side. The hypotenuse is over here, so 2/3 is that triangle then. Okay, doesn't matter what the initial triangle looks like as long as it's right. Doesn't matter where the theta goes as long as it's not the right angle. But once you place both of those, then order matters. Okay, now we need to find tangent. Tangent uses the adjacent side, as does cosine. So we need to know our adjacent side before we continue. And to do that, Pythagorean Theorem, right? Leg squared, we're missing it, so I'm going to use x to represent my missing leg, plus my other leg squared equals my hypotenuse squared. So x squared plus 4 equals 9. Minus the 4, x squared equals 5. Take the square root, x equals the square root of 5. And there is your adjacent side, so square root 5. And now you can find the tangent and the cosine. So tangent, remember, is the opposite over adjacent. Opposite to adjacent root 5, so 2 over square root 5. Answer. And then our cosine of theta is going to be the adjacent over hypotenuse. So adjacent over hypotenuse, so that's root 5 over 3. And there you go. There's your answers. So the biggest thing is making sure that you remember which code word, right, what it represents as a ratio, as a comparison. And once you do, a lot of these go by really quickly. They're not that bad, but it's a hard time remembering which sides are which for which ratio. Right? So just keep an eye on it. Make sure you take your time with it. Simplify what you can. Thanks for watching.